Okay, 1.9 is also your Chapter 1 test review. Okay, so we did talk today about dividing radicals, and so I want to do a problem for you on that. Number 16 is one of those problems, and it looks like this. Okay, so what I have here is I have a monomial that is being divided by a binomial. Okay, again, monomial means it's got one polynomial or one term, and a binomial means that it has two terms. Okay, so what I want to look here is I want to see, can I get rid of this radical, this root in the denominator all by itself? Because remember, no roots are allowed in the denominator. That's what the whole problem of this lesson was, is that we have to get rid of the root in the denominator. Okay? And unfortunately, the square root of 3 just equals a decimal. I cannot pull any pairs out or anything and break them up. So we need to start going through the process. The first thing is, simplify the denominator, okay, which I actually already did, and unfortunately the answer is no. So we have to go and create our fancy 1. Okay. When I create my fancy 1, because this is a binomial, I have to take into account that I need to multiply by a binomial. So what is it going to look like? Well, it's going to look exactly like the denominator. Okay, and all I'm going to do is change the sign in the middle. So instead of being a plus, it's going to become a minus. Okay? Now, when I multiply this out, it's pretty easy as we did it yesterday. This square root of 3 gets distributed, so the outside is a 1, so it becomes 3 square root 3. Then I distribute it again, and it becomes minus the square root of 9. And I'll go back and simplify that here in just a minute. Let me go ahead and slide this down. I'm going to create a box and do the multiplication for the denominator real quick. Okay, so there's my first guy. He comes down on the side, and then I'll put the other guy up here. Keep in mind that you need to keep your negative with the square root of 3 there. And let's go ahead and do this multiplication. 3 times 3 is 9. Minus 3 square root 3 plus 3 square root 3 minus the square root of 9. Watch what happens when I pull it out. I have 9 minus something plus the same thing, it's going to cancel, minus the square root of 9. So the 9 cannot be simplified. Hopefully you notice that these are the same but opposite signs of each other, therefore they cancel. Remember in class I told you that if you choose the correct complex conjugate, fancy 1, this will happen. If it doesn't happen, you chose the wrong thing. Go back and restart, okay? And then this guy right here, the square root of 9 is just 3 and 3, so circle them, take one to the outside, it becomes minus 3. So the entire denominator actually just becomes a 6, which is really, really nice, okay? So now we need to go back up to the actual problem and start simplifying it some. So I can't do anything with 3 square root 3, but I can replace the square root of 9. It's the same thing as substituting in a 3. All divided by 6. Okay, there's no root in the denominator. Check. Okay, scroll that up here. No root in the denominator. We did our fancy 1 in that. The last step that we need to do is just reduce it, simplify it. See what everybody has in common and cancel that out. So if I'm looking here, okay, at this guy, I can see that 3 is 3 times 1, 3 times 1 is this 3, and 6 is 3 times 2. They all have a 3 factor in common. I can take that away from everyone, okay, and it's all in the same spot. It's all the coefficient, the number that's on the outside, okay. So what does that leave me with? Well, let me zoom this out just a little bit. It leaves me with the 1, square root 3, minus 1, all divided by 2. They don't have any letters I have to worry about, and only one of them has a square root part. So of course the other two don't have that in common. So the actual answer, and I'm just going to rewrite it real quick, is the square root of 3 minus 1 divided by 2. Because I don't necessarily always like to write this 1 that's out front, because it does become a little cumbersome. But that's your answer to number 16. Okay? So I'm going to zoom back out and see if you guys can see the whole screen in case you want to go back and look at it. Not really. But anyway, there is that. Okay?